Good morning, everybody, and welcome back to our second session of webinars, which is today we're going to do an overview of the MOTOTRBO IP Site Connected Capacity Plus and Capacity Max systems. Once again, we have Aldo from Motorola, and thank you, Aldo, for doing this for us, and really appreciate the fact that you've taken time to present this to us and to give us an overview of exactly what Motorola systems have to offer. Without further ado, I'm going to hand it over to Aldo. Thanks, Aldo, and it's over to you, sir.
Thank you, Grant. Okay, so today we're going to cover off the different topologies that are supported with our MOTOTRBO product, and we're going to look at operations operating in conventional operation, that including simplex operation and also through a repeater. And then we're going to talk a little bit more about what IP Site Connect is and the different modes of Capacity Plus as well as the Capacity Max systems. So let's okay. So basically, depending on the your customer requirement, it would depend on the type of system that you'd be recommending these solution for the customer. So primarily in conventional operation, that can be done in two ways. We talk radio to radio conventional, or as shown in this example, through a repeater. So that's our basic configuration. We have a single site solution in there. Look, roughly you could operate approximately a couple of hundred users on that configuration for conventional operation. Voice and data is supported in both those in this system, whether it's on one time slot or two. So as mentioned, there are two talk paths. As we know, in the MOTOTRBO world, we have two time slots when we operate through a repeater or even in conventional mode. We'll talk a little bit more about that. And the ability to integrate features such as transmit interrupt and many other features, as well as all the third-party applications, they're all supported in all of these modes that we're going to talk about. So it doesn't matter whether we're talking about simplex radio to radio or conventional through a repeater or IP Site Connect or any of the trunking modes. The third-party applications that we're going to mention in more detail in our next session next week, they are all supported in all these modes of operation. So moving from a conventional operation where a user is defined to a channel determined by his channel selector switch, IP Site Connect is the actual ability to connect multiple conventional repeaters together to form an IP backbone to form a wide area network. So the benefits of here would be in the situation where we do require the user to be able to get coverage beyond a single site. We can connect the repeaters together via an IP backbone. Hence the name, it's called IP Site Connect. So we can have up to 15 sites connected in this system, and again, approximately 200 users per site. It's not a trunking solution, it is conventional, but we still have our two talk path capability within this system. It is conventional based, so primarily if I'm a user that's programmed to work on time slot 1, it will link time slot 1 across all the sites, or I can also link the time slot 2 users across all the sites. One of the benefits with IP Site Connect is I don't have to have both the time slot 1 and time slot 2 wide area linked. For example, I could have a 3-site system where I may have one site in say Melbourne, one in Sydney and one in Brisbane, and we could have time slot 1 being the wide area link that will link all 3 sites together. But we can still have time slot 2 operate as just a local repeater, conventional repeater site, so that when we talk on time slot 2, we're only repeating at that site. We don't have to link that across the wide area. IP Site Connect can also, again, whether we talk about a large coverage area, if we're talking about along along, say, a road or a railway line, or if we're trying to get coverage across a larger city area, we can link those sites together. But again, keep in mind that IP Site Connect can be used in smaller locations, such as a hotel or a stadium or a building or a shopping centre, where we generally can't get coverage throughout the whole site with a single repeater. We may need to get multiple repeaters, say one down a west wing and one down an east wing, and then maybe one in a basement area or something like that. And the idea would be that our radio would be able to, doesn't matter which area they go to, the radio will roam. The radios do roam seamlessly from site to site automatically, and then the user will always be in coverage of a site, and they were able to communicate back, and everyone else will hear them as they're all on the same time slot. So that covers off our IP Site Connect, and we'll also go into a little bit more detail about another version of that, what we call Modo Turbo Link, but we'll cover that shortly. So that's our conventional setup. Then we move over to our trunking capability within our system. So there are three forms of trunking that we offer: the Capacity Plus single site trunking solution, Capacity Plus multi-site, and then we talk about our Capacity Max Tier 3 solution. So let me talk about Cap Plus first. So Capacity Plus single site and multi-site solutions are where Motorola have been able to take the radios and support what's called like a dynamic trunking solution, and this is unique to Motorola. So this is something that can only be done with Motorola radios. It's not defined as part of it, not to be confused with the Cap Max, which is the fully compliant Tier 3 trunking solution. This is a dynamic trunking solution that Motorola has implemented as part of the conventional trunking, digital trunking solution. So it's a very cost-effective solution. So we can have a single site which can trunk up to about 1,600 users, or we could go up to 15 sites and again get about approximately 1,600 users per site. The reason we say it's dynamic trunking is that it's a repeater-based trunking solution. So there's no system controller or site controller within this solution. So the trunking is handled by all the repeaters within the network, and the repeaters know what's the next channel available to allocate the user. So that's primarily the difference between a conventional system and a trunking system, is that a conventional system relies on the user to select the channel that they've been programmed to use, and they will be defined to a time slot. The difference in a trunking solution is now that we have a group of channels within the system, and the user now is, the channel selector is effectively now a talk group selector switch, and as they switch talk groups, when they hit the PTT button to make a call, they'll be allocated the next channel. We'll talk a little bit more detail about that. And again, this solution does support third-party applications tied into this solution as well. There is a limitation within the amount of trunked repeaters. You can have 8 trunked repeaters in a single site or a multi-site solution, so that's 8 trunked per site. Now, 8 trunked repeaters, remember we have 2 time slots, that effectively becomes a 16 channel system because of the 2 time slots. In those 8 trunked repeater channels, they can be a combination of voice and data channels within the system. However, if we start to get applications where we're starting to utilize things like text messaging, GPS tracking or indoor tracking and things like that, we start to become more data intensive within the system. So we have the capability to add extra repeaters to our system, to add them as data revert repeaters. So the idea here is, even though I did say we can use data on our trunked voice repeaters, however, we have to be wary not to overload the voice repeaters with data. So if we do know that we're going to have a high level of data application, we do need to consider setting up data revert repeaters so that we take the data load off our voice repeaters. If you put too much data load on your voice repeaters, you'll start having issues where users can't get access to the system to set up a voice call because a repeater is being used to send some sort of data back to the application. So we have the ability to set up data revert stations within that system. So that's the CAT Plus single site multi-site solution. Then we talk about CAT Max. Now CAT Max is it's about high capacity and high control of the system. We have up to the CAT Max supports up to 250 sites and approximately 300 users per site. It's a fully integrated, fully managed trunk network that is compliant to the DMR Tier 3 operation. So that means that other manufacturers of DMR Tier 3 trunk solutions are able to have radios operate on a capacity max system, or vice versa. Our MOTOTRBO radios can operate on a other manufacturer's DMR Tier 3 trunk system. It is a controller-based trunk system, and we'll learn a little bit more detail on that as we see more slides. And again, this system can integrate and work with third-party applications and support things such as dynamic roaming, priority calling, and other third-party application functionalities. These configurations are available in, can be operated in all bands, VHF, UHF, or more so in our New Zealand region, the 800, 900 meg, more so than Australia. Let's look in a little bit more detail on these systems. First, we'll start with conventional operation. So under conventional systems, we talk about direct mode operation, and that's where a radio just talks to a radio without even a repeater being involved. What's important to understand in this direct mode of operation, our first generation MOTOTRBO radios were released in 2008 through to 2012, which we were known as the DP3000 series and DM3000 series. These radios obviously did support direct mode of operation, but there was only a concept of a single time slot being operational during direct mode. Two time slot capability was only available if you operated through a repeater. However, and with the release of the DP and the DM4000 series product, Motorola did then have the ability to support two time slot operation even when operating in simplex mode and not through a repeater. So this does require the second generation of subscriber radios. It's not supported in the old DP and DM3000 series radios. And we do get two time slots without having to use a repeater. Now this is programmed in the using the CPS, and this is what we call dual capacity direct mode. So with dual capacity direct mode, now for a simplex channel, we can have two time slot users sharing the one simplex channel. So this is a fantastic opportunity for dealers that may be running rental fleets, or even where we have things such as construction sites where they are using simplex channels, and now we can get two channels for the price of one. So the radios do support that two time slot operation within simplex, and as I said, it's called dual capacity direct mode. And the time slot synchronization is handled amongst the radios, so the radios pass that synchronization on to each other so that they know which, and there's time slots to synchronize the whole time. So that's direct mode of operation, radio to radio. Then we move into repeater operation, so conventional, digital, and also bearing in mind that these also support analog operation. But repeater in digital is TDMA operation, as we said, so by two time slot capability within that. So for every RF frequency, two channels. And as I said, we mentioned the extension of conventional operation to do multi-site operation. We for doing IP, but also in firmware release 2.9, Moto Turbo Link, and primarily Moto Turbo Link is the ability to do wide area solution instead of using an IP backbone. We use repeaters to
hey, Aldo, I think your
links
microphone,
sites.
your microphone is going a bit scratchy.
It's going a bit scratchy. Yeah, I think it's something to do with the bandwidth, because I haven't changed anything. I've sat in the same position. Is that any better at the moment?
Yeah, this is much better at the moment.
It's not pixelating badly.
So are you going 4.5?
Sorry, what was that, Grant? I missed that.
No, I wasn't saying anything. Somebody else seemed to be jumping.
Okay. All right. So I'll try to talk a little bit louder, but sorry if the pixelation there. I'm not sure if there's
just Elder, quickly before you carry on, guys, if you want to post any questions, I know we didn't mention this before. There is a little questions folder where you can type in all your questions. So as we're going along, let's have this interactive. If you guys have got questions as we're going along now on the slides that we're on, post the question and I'll ask Aldo straight away so we can answer that question while we're on the slide. So part of the actual presentation, you'll see you've got a questions folder. If you type your questions in there, we'll get to them straight away. Sorry, Aldo.
That's right. Okay, so and as I mentioned, so Moto Turbo Link is the ability to then set up a wide area solution using repeaters as RF links as opposed to an IP network. And we'll see that cover that off in a little bit more detail in the slides. Okay, so
just before you run off there, so this question, we've just had a question posted. And Aldo will answer this question in the next two slides coming up as well. But the question being posted in dual capacity direct mode, anytime there's a delay noticeable when using a single frequency with 2 time slots. Any lockout of channel when one time slot TX is before the other. All right, Aldo can go ahead and answer this, but Daniel, you're misinterpreting what we're talking about, the 2 time slots. You're going to get an automatic delay in digital purely because we are converting signals from analog to digital, then transmitting it and converting it back. So there's always going to be a delay in digital. It's got nothing to do with whether you're on time slot 1 or time slot 2, or whether we are transmitting on 2 time slots. That's got nothing to do with the digital delay. I'll leave Aldo to get into the difference between TXing on the 2 different time slots, which we're about to do now anyway.
Yeah, so primarily when we talk about, I mean, at this slide, we're going to talk a little bit about just going through a repeater, but it's no different when we talk about dual capacity direct mode. So as I said, when we run 2 channels, 2 time slots in simplex, it's programmed within the system to say this is the simplex frequency, and a user will operate on time slot 1 or a user will operate on time slot 2. They are 2 independent slots, so they will not interfere with each other. What's happening on time slot 1 has no bearing on what's happening on time slot 2. As far as users having whether you want to utilize functions such as channel busy lockout on users to stop users from talking over at the top of each other, that's normally defined within the time slot. It's not, as I said, what happens on one time slot does not affect what might be happening on another time slot for that user. As Grant mentioned, in the digital world, there is always a delay, and we need to understand that that is inherent in the system. It doesn't matter whether we're going through a repeater or from radio to radio. The delay is not the delay in the transmission path from radio to radio, or the fact that it goes through a repeater and that may be further away. The delay is purely related to the digital signaling and processing being converted from analog to digital, and that's where the delay talks about. The other thing that I probably should have mentioned on the previous slide was that the digital, when we talk about simplex operation, the first generation where it wasn't 2 time slots, the 2 are mutually exclusive. So if you're running in conventional, in digital simplex in the old mode and not dual capacity direct mode. They are two different modes of operation. So you can't mix normal radio to radio direct mode operation with dual capacity direct mode operation. So it's one or the other. You can't have both operations in the one on the one frequency.
Can I just make another comment here quickly, Aldo, on the delay? Chaps, you mustn't get hung up on this delay. You will only notice that there's a delay in digital if you're standing next to each other. The only operation that's out there that really could get hung up on delay that causes an issue are crane operators. We're talking 350 milliseconds here, guys. 350 milliseconds is the delay we're talking about. Every single digital implement out there, whether it be your cell phone or whether it be a DMR digital to a radio, has got delay in it. All right. So if you make a phone call to somebody on your phone and you're in the same room, there's a delay on it. Nobody moans about that delay when you're talking to each other on telephones, because you don't know that delay is there because you're not standing in the same room with each other. So please don't let your customers get hung up on the fact that there's a delay in digital. Yes, there is, but every single digital signal has got delay in it, and that includes your television. All right, so don't get hung up on delay. Thanks, Aldo.
Okay, no problem. All right, so when we look at now the operation of two time slots, so as can be seen, when a user is programmed in the conventional mode of operation, they are programmed to work off a particular slot. So this one maybe is told on this channel you are transmitting through time slot 1. So when they transmit, they operate through time slot 1. And again, at the same time, the second user, generally with a different talk group, would be programmed to operate off time slot 2. The two radios can communicate at exactly the same time through the same repeater frequency without any impact to interference because they are operating on two different time slots. So always think of, even though it's the one frequency, always think of time slots as a different channel within the system. Then with D key, we go back to our web operation, and we're still on that programmed on that same time slot. Now, to take conventional operations one step further, I talked about IP site connects. It's basically the ability to connect repeaters via an IP backbone. In this case, you can see 4 repeaters that may represent 4 different sites that could be in 4 different cities or 4 different suburbs, or could be in the same shopping centre but in 4 different areas, so that we get coverage throughout the whole area depending where we are. And what you'll, again, so these are still operated in conventional mode. We're still talking about conventional operation. So you're defined to a slot in the system. And you can bear in mind that you actually can still have users in conventional digital operation, be it single site or this IP site connect multi-site operation. You can actually share users onto the same time slot. But bearing in mind that if you're sharing a time slot, it's you only have access to one user at a time on that time slot. So, for example, here we have an IP site connect switching over. A were to hit the PTT button to set up a call, as you can see via the IP backbone, that will cause the repeater at all the different locations on time slot 1 to key up on the network. And any user that is in coverage of that repeater and their radio is on the channel programmed to slot 1, they will hear that communication come out through their if the transmission cannot be repeated because time slot 1 is already occupied. So if you have a look at the second side, talk group B user has tried to key up while talk group A user is using time slot 1. The talk group B user will get a channel busy in this case because talk group B is told use time slot 1, just talk group A are. But while talk group A is utilising that channel, talk group B cannot key up, they have to wait for that channel to be free. So this is only if we share users on the same time slot. Once if someone in talk group C was key up at this point in time, that's fine. They're on time slot 2. They're programmed to work off a different time slot. So as you can see, in this case, talk group A can talk at the same time as talk group C. Talk group C is on time slot 2, and it will key up time slot 2 at all the other sites and allow those users to hear that conversation. So at site 1, time slot talk group C is keyed up on time slot 2. If that user was to dekey, that time slot will become free for anyone else to that might be on that time slot. It also gives the opportunity for the person at site 2 to key up and talk back to that user on site 1. So we have a wide area of communications across the time slot. Then, if everyone dekeys, then the system becomes idle and users are able to then key up as required. In this case, talk group B user would be now free to key up because talk group A user finished the call. Just remember that when we provide a site, if there is overlapping coverage,
You're breaking up again, lad.
Sorry, so were you actually then when you responded? So it must be the
we've got a bandwidth issue somewhere, folks. We do apologise for this. I think it's with everybody working from home. I think the NBN's getting throttled. We'll just keep going.
Okay, let me know if it gets really bad. But yeah, when you replied, I heard what you must be hearing from me. So when we have a multi-site, solution. And there is overlap coverage with the repeaters must be on a different frequency. Otherwise, if you transmitting on the same frequencies on 2 repeaters with overlap, you will get simulcast distortion. Our system does not support simulcast capability. So the frequencies must be different. If the repeaters are geographically separated by a long distance, for example, if I have one operating in Brisbane and one down in the Gold Coast, and you're not going to get overlap between the two, then there's nothing stopping you from reusing frequencies within that system. There's also the potential that if these sites are diversely located, you could have one repeater be a VHF repeater and the other one be a UHF repeater on the system, and you can patch through a VHF to a UHF because it's just passing voice and the PTT commands via the IP backbone. So obviously the VHF radios would work at the VHF site, the UHF radios would work at the UHF site. So you could link disparate frequencies across an IP backbone. And the other point, as I mentioned earlier, is that you don't have to link both time slots. You can set it up so that only time slot 1 is wide area linked, and time slot 2 could be just a local repeater when we work off that time slot 2, and it would not cause time slot 1 to key. Sorry, it would not cause time slot 2 at the other sites to key up. The last thing I want to mention here is radios in IP Site Connect mode. When we program the radios, we program a roam list within the radio. So the radio has a list of all the sites that make up the IP Site Connect network, and the radio can roam from site to site without the user having to try to think of what channel they need to select within the system. The radio, when we set these up, are programmed with the roam list, and they rely on the received signal strength indication on selecting the site which they need to roam to. In the absence of a voice on the system, a radio may still be moving around even though there's no one talking on the system. So therefore, you won't be able to find the site if it's relying on the received signal strength, the RSSI. In that situation, the system also has the ability to set up repeater beacons. So with the lack of voice activity on the system, the repeaters will key up at a programmed interval, and all the sites will key up at once. The radio can then realize, okay, I can see now the forward or however many sites it can see, and it will base its roaming on the beacon and the signal strength coming from the repeaters. So the radio will either roam based on received signal strength while it's receiving, or during a repeater beacon if due to lack of voice activity on the system. Okay, as I mentioned, that's previous IP Site Connect. As the name suggests, it's the sites are connected via an IP backbone. In release 2.9 of MotoTurbo, we introduced a feature called MotoTurbo Link, and MotoTurbo Link is basically a different way of configuring a conventional wide area network. And primarily, the main difference is instead of using an IP backbone, we now link the sites via over the air via a backhaul of repeaters linking the sites together. So we still have a voice repeater for our network where we're talking to voice, but then we have RF link repeaters that link the sites. Now this is useful in situations where they might be fairly remote locations where there's no IP connectivity to support an IP backbone link. Bearing in mind that MotoTurbo Link does have its limitation now because we're using over-the-air RF links. The timings are quite, the timing delays are quite a bit longer compared to an IP, because remember, IP, basically your delay or your ping, if you ping a site, that gives you an idea of the delay you might have from site to site. It may be 5, 10, 20 milliseconds or something like that. When you're doing over-the-air RF linking, then one site will key up to cause another site to key up, to cause another site to key up. So all of a sudden, the network is a little bit more susceptible to delays within the call setups. So because of that, MotoTurbo Link is not deemed to be a high capacity, a high throughput configuration of a site. It is really for those quite remote, quite rural, low density, low volume sites. And as I said, it's in absence of an IP network. So the communications is done via the land mobile radio channels. And bearing in mind that MotoTurbo Link is only supported on the SLR repeaters. You can't do it utilizing the old NTR or DR3000 repeaters. So this is the ability to, so we still can do things such as GPS tracking and text messaging through this network. But as I said, bear in mind there are some limitations compared to IP Site Connect. So if we look at the next slide, it gives us an example of maybe what a MotoTurbo Link system could look like. In this example, it shows, so for MotoTurbo Link, we can support what we call up to 8 hops. So effectively, let's call it 9 sites in a chain. And MotoTurbo Link can also support up to 15 chains. So 8 hops per chain and up to 15 chains connected together. So it's quite a large capability within the system. As can be seen in this diagram shows 2 chains, one to the left and one to the right, and these are linked together back at a point where we do have IP connectivity. The chains can be linked together via an IP Site Connect network. But I guess what's important to understand here is if we look at the repeaters that are non-coloured, that have just a white background, they would be considered our normal voice repeaters. So we still have 2 time slot capability. We talk, again, we can decide whether we want time slot 1 just wide area linked, or time slot 1 and time slot 2. When you'll see that the voice repeaters are then connected now via an IP switch just within that site. So there's no outside IP network required, just an IP switch within the site that connects the voice repeater to the link repeater. And so what happens when a voice repeater keys up, it'll key up the link repeater. The link repeater will be programmed to transmit to a frequency at the next site. which will receive that information and cause it, the repeater, to key up and transmit over to the next site, etc., etc. And this goes across all the sites. Now, what can be seen on this diagram, at the originating site and at the terminating site, there is one link repeater at those sites. However, at all the interim sites, there are two repeaters, one for a forward link and one for the backward link between the sites. So as I said, this just shows a 3-site system: originating site, interim site, and terminating site. We can have up to, as I said, 8 hops or 9 sites within a link. So there would be one originating, in a 9-site system, there'd be one originating site, one terminating site, and then 7 interim sites. And all those interim sites would require 2 repeaters in the network. So the IP, so when our voice comes into our voice repeater via IP, that's passed on to the link repeater, then the link repeater transmits that voice to the next link repeater, and so on and so on. So as you can see, once the voice repeater connects to the link repeater, all the hopping from site to site requires a link repeater to key up to connect to the next link repeater, to key up to connect to the next link repeater. So all of a sudden we can start introducing quite bigger delays than would be normally seen on an IP site connect system, which, as I said, probably at a maximum we would say 60 millisecond delay from our IP pings that we set up in an IP site connect network. However, in a link network, you can imagine if we're linking from 9 sites in one chain, potentially to the end of a 9th site in another chain, you can potentially have up to about 1.5 to 2 seconds delay between the audio from one site to the other. So that's why things such as transmit, interrupt, and all these and some of these other features that require critical timings. That's why we talk about some features are not supported in MOTOTRBO link mode compared to IP site connect mode, because all of a sudden the timing delays are quite large. And as Grant just alluded to before, it doesn't matter the fact that the audio gets there potentially 1.5 seconds later, because primarily you don't hear the delay because you're not hearing both sides. If you're 9 sites apart from one chain to 9 sites apart from another chain, it's highly unlikely you're going to be hearing the audio at the same time. So you're not aware that delay is there, but that delay is in there. And bearing in mind that, as I said, still through our network, we can still run the third-party applications that we'll talk about next week, and the network monitoring tools such as RDAC and things like that. They can still all be run within the network, even though it's not an IP network. As I said, just bear in mind that there are limitations with this network. Okay, so that's the wide area conventional operation. Let's talk a little bit about repeater-based trunking systems. The first two we'll talk about is the capacity plus single site and capacity plus multi-site. So as we mentioned, you can have 8 voice trunked repeaters in the system, which is equivalent to 16 voice channels. And we can also have a 12 data revert repeaters per site. Now, bearing in mind that we can have 12 data revert repeaters, but at a particular site, we cannot have more than 12 repeaters in total. So what I mean by that, if I have 8 trunked voice repeaters, I can only have 4 data revert repeaters at that site. If I have only 4 trunked voice repeaters, I can have 8 data revert repeaters. So as it's a total of 12 repeaters at a site. We call it repeater-based trunking because, as I said, in the absence of a site
We've lost you, lad. The last word was in the absence of a site, and then you were gone. Looks like we've lost Aldo, folks. All right, so what Aldo was actually saying there is using capacity plus single site, capacity plus multi-site, there's no need for a control channel. So in a repeater-based trunking system, there isn't a control channel. The repeaters themselves control the trunking by placing your radios that are on the system onto what we call a rest time slot. So,
Okay.
You back?
Am I here? You can hear me now? Yep. Somehow the system told me it lost my voice communication.
Okay, you're back. You're up to you.
Okay. Where did you lose me?
You were talking about repeater-based trunking and that you don't need a control channel, and that's as far as you got.
Okay. Yep. So I mentioned about the total of combined 12 repeaters, combination of trunked and data revert. I can have 8 trunked and 4 data revert, etc. Okay. So we can integrate, again, third-party applications into this system, and again, it's available in all the bands, and mention that we can actually utilize this solution, whether we're using DR3000 and MTR3000, so it is supported on obviously the older configurations, as well as the newer SLR repeaters are supported in the system. Okay. All right, something seems to be happening with my PC. It keeps muting. All right, so let's have a look at how this works. So the problem we have with conventional versus a trunked approach is with conventional, as I mentioned, we are defined on a system. In conventional, our radio is programmed to operate off a particular time slot. So a user will have to be at that site on that time slot to be able to communicate through that. Sure, we can have IP Site Connect where we can talk to each other as long as we're on the same time slot, but we are defined to the channel that we're set to. The difference being, so now the user must select the channel to be on that. So if I'm on channel 2 on a conventional system and the user is on channel 1 and they want to do a private call to channel 2, they can't do that. They would have to move over to that channel to set up a private call. However, when we talk about a trunking system now, we pull all the channels together, and then as a user, we are defined by a talk group switch, or we now connect as a talk group. So we might be the maintenance team. So the maintenance team will switch to the maintenance talk group. And when we key up on the system, we will get allocated the channel. So everyone within that talk group will be allocated the channel. And one of the benefits in the trunking approach is that where if I want to make a private call to a user, even if they're defined to another talk group, I can still, as long as I know the ID of that radio, I can still set up a call to that radio user, even though he's programmed onto another talk group. So let's a bit of an explanation about Capacity Plus, and then we'll have a bit of a graphic to show you how it works. So for Capacity Plus single site trunking as a solution, it utilizes what we call a rotating rest slot. So as I said, it's a dynamic trunking solution, and generally users will sit idle on that rest slot. Once they want to set up a call, that rest slot will be converted into a voice slot, and any non-participating members of those calls will get told to move to a new rest slot. Now, to set up a system with Capacity Plus does actually require you to license the repeaters to support this functionality. Now, the licenses for a Capacity Plus single site solution is listed there, the HKVN 4013, and that's the license if you're using a DR3000 or an SLR 1000 or an SLR 5000 in Cap Plus mode. Alternatively, if you're using MTR 3000s and SLR 8000s, for some reason Motorola decided to give the license a different part number, but it's still a Capacity Plus single site license, but as you can see, it's a different part number required if you're using MTR 3000 or SLR 8000 repeaters. As you see, we can go up to a total of 8.
Elder, you gone? Okay, folks, I think what Alder was saying as he broke away there was you can go to a maximum of 8 voice and data repeaters. So you'll see that represented on the bottom of that graphic, where you've got time slot 1.1, time slot 1.2, and that'll go through to your 8 voice channels, which will go to 8.1, 8.2, which gives you 16 possible voice time slots that are available on that site. You can then have an additional 4 repeaters if you've got 8 voice and data repeaters, primarily and dedicated for your data transmissions. So that'll give you a total of 12 repeaters on any one of the possible sites. Like I said, we're in single site solution, so the single site is going to have a maximum of 12 repeaters at that site, which can then be a combination of voice and data, which is what's graphically shown there, or you can go then to data only, data revert repeaters, depending on how much data you're going to be pushing across the system. I don't know if Elder can hear me, but if you can jump to the next slide, we can work through that. No, looks like Elder's got a problem with his PC. It might be frozen here. Bear with me, guys. Let's see if we can get this all back.
1, 2. Test 1, 2. Test
Yep,
1, 2.
that's back. I've got you back. All right, lad. What I've done is I've gone through that slide explaining the time slots.
Yep.
So time slot 1.1 down to 8.2, and went on to explain the 8 voice and data repeaters, and then on to the 4 data only repeaters, or a combination, to give us a total of 12 repeaters for that site.
Sure. Can you still hear me? Test 1, 2.
Yes, can. You can carry on.
Yeah. Okay. All right. Sorry, guys. It obviously is an internet connection problem. So with Capacity Plus, as I said, all the trunking is done amongst the repeaters. And here's an example where this is a single site solution, right? There's not 4 sites. Think of this all racks together in a single rack. All the users, when they're idle on the system, when no one's talking, they may be on different talk groups, but they're all listening to the REST slot. The REST slot is beaconing information out to say, hey, everyone sit here while when the call gets set up. So a user then may, user A would hit their PTT button to set up a call for all talk group A users. Everyone that's part of talk group A will stay on this slot. This REST slot would be converted into a voice slot, and all users as part of talk group A would stay on this slot. And anyone that's not party to this call will move over to slot 2. When another user group wants to make a call within the system, they will hit their PTT button to key up, and the system will say, okay, use the voice slot. Anyone that's not party to this call, go to slot 3. So as can be seen, there are 2 concurrent calls taking place on the first repeater on the site, and any users that are not party to that call will be on slot 3 as the REST slot. When a user dekeys their radio and no one talks back in the designated hang time, the system tells all the radios in that talk group, says, hey guys, the REST slot is currently on slot 3, so your call's finished, so you will move over to slot 3. This will continue on as users key up the system. When I set up a call and I grab a channel, I will grab that slot, and all users that are not party to that call will move over to that REST slot. In this system, one of the benefits, and this would go so on through to all 8 slots. The system also does have a little bit of resilience in the sense that if I were to lose one of the repeaters, let's say the 3rd repeater, which represents slot 5 and 6, the repeaters do send keep alive messages to each other, and in the absence of a keep alive message, the other repeaters will know that that repeater is not functioning correctly, and therefore it will leave that out. So when the REST slots, if there's a problem with the 3rd repeater, the REST slots that get allocated will be slot 1, 2, 3, 4, 7, 8, 1, 2, 3, 4, 7, 8. It will never allocate slot 5 while there's no communication to that repeater. If for whatever reason for that repeater failing comes good again, whether it was a power a problem with that repeater, or replace the repeater, Once that repeater comes good, it sends keep live messages amongst the system, and they're then able to communicate amongst each other, and it will reform as part of the network and will allow that those slots to be allocated back to a 8-channel system as opposed to a 6-channel system. So as we know, there's great benefits in two time slots per frequency because it gives us more channel capacity, but bearing in mind that when we lose a repeater, we do lose 2 channels within the system. Again, these are just set up as voice channels within this system. If we had data revert channels, they would be connected into the same switch, but the data revert channels would purely be used for the radio sending data back to the third-party application. When all calls are finished on the system and no one's participating in the calls, the users will all sit on the rest slot waiting for the next call to take place. One of the things that's good to understand in a CAT+ system is, I'll just go back a slide and show in this situation. We have the ability, in the first session last week, we spoke about the capability of all call within a system, and in a conventional system, an all call will call all users that are on the same time slot. Slightly different performance in CAT+, because in CAT+, all users are on the rest slot when a call is not taking place on the system. So when I set up an all call, I will actually grab all users that are not active on a call, but also the system will send out an active message on the two, in this case, in this example, the 2 active slots, slot 2 and slot 3, and send out a message to all the users that are receiving on those 2 time slots to say, hey, there's a all call taking place on slot 4, and it will actually take those users off those calls and off talk group B and talk group C and move them over to slot 4 and set up an all call on slot 4. Now, the 2 guys that are hitting their PTT, or the 2 people that are hitting their PTT button in talk group C and talk group B, they don't get dragged across initially, but when they let go of their PTT button, they will get the message to say that an all call is taking place on slot 4, and they will then move into that all call. So all call is quite a powerful call in that it pulls every user on the system into the one call. It's a system-wide or call within the network. Very powerful call, bear in mind with that. So that's how our Capacity+ single site solution works.
You're gone again, son. You're breaking up. Just to reiterate, folks, while we're waiting for Eldar to rejoin us, that all call, if you're going to be using that in an IP Site Connect solution, you need to generate an all call per time slot in that IP Site Connect system. So in IP Site Connect, time slot 1 needs an all call, time slot 2 needs an all call across the IP Site Connect solution. If you're going to be needing an IP or an all call that goes across every user without having to have somebody selecting different channels, convince your customer to come to Capacity+. Capacity+ for me is a much more versatile solution than IP Site Connect when you need to do fancy calling and you really need to get people involved in emergency calls and calls onto single channels and try and group people together. I just find Capacity+ a lot more advantageous than going IP Site Connect.
Back online.
Good lad, it's all yours.
I must apologise, guys. I'm not sure this went quite smoothly last week. I'm not sure why it keeps locking up this week. So a multi-site trunking solution is really just connecting more Capacity+ single sites together to form a wide area network. Now, when we set up this network, what's important to understand in a Capacity+ multi-site network is that only repeaters are able to sit at a site within the network. We can't have it sharing repeaters and then other infrastructure within that LAN. So each site is its own LAN network, and you can see that the repeaters are still connected via a switch at the site, and then the site normally lives behind a router. Now, the reasoning for that is there's some messaging that takes place within the system, broadcast messaging, that must be contained within the site and not get out of the site. Another option is to use layer 3 managed switches. They can be used in the event of non-routing, but generally, basically, each site must be within its own LAN. You need to define the call setups in a wide area network because Capacity Plus multi-site does not have a site controller. It's not able to determine where users are within the system to set up calls across different sites. So you determine when you program up the system as to whether a call will go out to all sites or just 2 of the 3 sites or 5 or 7. You define where the calls get set up within the system. With Capacity Plus multi-site, they are slightly different licenses to a Capacity Plus single site, and these are the licenses shown for both the DR, DSLR repeaters, or the MTR and the SLR 8000. So these are Cap Plus multi-site.
Elder, while you're there, won't you just discuss quickly the difference between, because this license you're showing is for the Capacity Plus multi-site. Please won't you also just discuss quickly the incremental licenses and the benefits of that? Yeah, the migration. Thanks, sir.
Yeah. Okay, so as was alluded to, so if I had a customer that had an existing Cap Plus system and they then decide a single site solution, then they decided to migrate to a multi-site solution because they were growing in coverage, we have the ability to have what we call an incremental license, where we upgrade the repeaters from their existing Cap Plus single site solution into a Cap Plus multi-site solution. So there's slightly different part numbers because we're saying you've already got Cap Plus single site and it's a migration to Cap Plus multi-site. Now, what's important to understand that is if you have a system that you're setting up for the first time and it's only going to be a Cap Plus multi-site solution, then you can go with the Cap Plus multi-site licenses that are fixed as a multi-site solution. However, when you do that, it doesn't necessarily mean that those repeaters can be utilized within a Cap Plus single site solution because you've only purchased the multi-site license. So what a lot of our dealers do, and it's potentially a smart way of doing it, is if you ever want to implement a multi-site solution, you're better off buying the Cap Plus single site license first on the repeater, and then buying the incremental license that brings it up to have capability to do Cap Plus multi-site. And that way now our repeater has a license for a single site solution as well as a multi-site solution. If you just buy the Cap Plus multi-site full license right from the start, you can't use these repeaters in a Cap Plus single site solution because they're not licensed that way. So it's actually smarter to do a Cap Plus single site license and then do a Cap Plus incremental multi-site license, so that way we can use them in both systems. Grant can go into more detail in discussing that with you guys at a later date.
Absolutely.
But we have similar configurations when we talk about multi-site solution, i.e. meaning we still have 8 voice channels, 8 voice repeaters per site, which is 16 voice channels. They can be voice channels only, or they can be voice and data channels if we want to put in data revert repeaters. So the same rules hold true for data revert. Have you still got me now? Yes, still talking. Okay.
Yeah,
all Capacity Plus multi-site repeaters must be separated by routers. Even on a private network, the individual sites need to be routed to and from the LAN and the WAN. So as I said, they do set up messaging amongst each other. So for example, when we have if we have a break between us, a link between site 1 and site 2, the sites will still form as single site trunking. In this situation, the site will trunk as a standalone trunked site if it loses connectivity to the other site, because they send that broadcast messaging amongst each other to form as a single site network. When our IP link that did come down reforms, and it connects back into the wide area network, then the system will self-heal and reform as a wide area solution within the system. We do have the ability to integrate what a functionality called RDAC. RDAC is Repeater Diagnostics Alarm and Control software that allows you to monitor the health of the repeaters. It monitors the DC supply, BSWR, receive, power levels, etc., within the system. Now, RDAC does that. There's also, you'll find that the third-party applications such as the TurboNet and the Smart PTT solutions offer a similar monitoring package within their networks, which pretty much does what RDAC does within the network. That's our multi-site solution. Then the last thing that we want to talk about is what we call our controller-based trunking system. So this is the CapMax solution. So our CapMax is our dedicated DMR Tier 3 solution. Our next generation can be run as a single-site or multi-site solution. So we have full trunking control functionality linked over an IP network, okay? There is a dedicated trunking channel, control channel on each site, at every site. So all that, what I mentioned about moving rest slots in Cat Plus single site and Cat Plus multi-site, that's very unique to that pseudo trunking system. Now we're back to a more traditional trunking system where every site has a control channel repeater. The CapMax system relies on one centralized control server to run the whole network. We can have up to 4 redundant controllers within a CapMax system servers within a network. Obviously, a 250 site system, you're not going to rely on potentially just one controller being the main point of failure. So we do support the ability to have redundant controllers within the system. Within the CMSS, there's a centralized fault and performance management tool called the System Advisor, and that's part of the CapMax system server. So we don't utilize the tools such as RDAC. That's not utilized in CapMax. It uses the System Advisor tool that's built into the CMSS. The CMSS is also used for optimizing the routing, the signal and calls of traffic within the system. So what we mean by that primarily is in this system, it's quite a flexible system. We can have what we call distributed control and centralized control distributed voice, or we can have a combination, or we can have centralized voice and centralized control. So what we mean by that is when a call gets set up, the radios will talk to the CMSS to set up that call. If a call only needs to go between site 1 and site 2, because that's only where the radios are registered to that talk group, then the calls don't have to pass through the CMSS. They'll just go from site 1 to site 2 within that system. If we are using any applications or system recordings or GPS tracking through our VRC gateways in the system, then that traffic does go through the controller within the system. Even the voice goes through the controller. One of the other benefits of a distributed voice is that we have to replicate our voice depending on how many sites we go to. So if we have actually quite a remote site and we need to set up a call from that site and that passes to say 13 other sites, there's potentially not enough bandwidth allocated at that site to be able to replicate those calls and send it to all 13 sites. So we can actually define within our system for a site to needs to act as a dedicated control. And what that means is now when it needs to pass audio to all the other sites, instead of it doing it distributed and replicating it to all the other sites, it sends it to the CMSS, to the server, and the server then replicates that and passes it to all the sites. So therefore, we don't have the problem where we don't have enough bandwidth at that site, obviously we make sure our main core has got the highest level of bandwidth, and then that distributes the call to all the other sites within the system. So you can mix and match how you set up your network regarding distributed or dedicated voice capability within the system. It's obviously a high coverage, high capacity system up to 250 sites, remembering that our CAT Plus multi-site only went to 15 sites. We can have 15 voice and data repeaters in the systems, as opposed to, remember, the multi-site system only supported 8 voice and up to 12 data, but in total only a combination of 8 voice and 4 data. So we have 15 voice repeaters that can be 30 time slots. One is a dedicated control channel, the other 29 can be used for voice and or data. And as we said, as we start to get users and utilizing more and more data, we need to be wary that we don't overload our voice channels, and we can add additional data-only repeaters within the system. So very similar to CAT Plus multi-site. We can do similar configurations in CAT Max. The other thing that I think is really what we consider the main importance or the difference between a Tier 3 trunking solution as opposed to our CAT Plus multi-site solution is the intelligence within the network, and the call setups are all within the controller. So basically, in a CAT Plus multi-site solution, whatever I program in the radio is the privileges that that radio has on the system. However, in a CAT Max system, it doesn't matter what I program in the radio, it's what's set up in the system controller, and what we call the SAT table, subscriber activity table within the system. That defines the capability of the radio, what calls it can do within the system. So we can program a radio that's got all the call capability, but at a system level, we define that. So one of the benefits, if I want to change the capability of a radio, currently it's not allowed to do private calls, it can only do group calls. But if I want it to be able to support private calls, rather than having to reprogram the radio to support that private call functionality, I just turn on the feature in the controller, and now that radio can do private calls within the system. So everything's controlled from a system level. The CMSS, high security, high resilience within the system. The network is still basically an IPv4 network. We can, with the option of setting this up through VPN. It's compliant with the DMR Tier 3 mode of operation. As I mentioned, vendor is supported within this system, but bearing in mind that the interoperability functionalities within the solution, there's only 7 defined mandatory interoperability standard features. Outside of that, then each manufacturer does tend to do the functions differently within the system, but as long as those interoperable features are there, any radio will support within the system. I can have different radios from other manufacturers on my system. There is licensing required. It's a little bit more complex when setting up the licenses with this. So if you ever have an opportunity in CAT Max, please work with ACE, and then ACE will work with Motorola. But there is licensing requirements within the CMSS depending on how many sites you have, how many controllers. We talk about gateways. So when we're including data applications that include voice recording, GPS tracking, and geofencing and things like that, these applications come into the network via gateways. So we have to set up voice and data gateways within the system. So depending on how many gateways, voice and data channels we need, they're also licensed. The number of sites licensed, the number of talk paths that we use within the system are also licensed. That's within the CMSS. Then the repeaters themselves, when we set up a repeater, just like I made mention, we need CAT Plus licenses in our repeaters. If we're using them in CAT Max, the repeaters need to be licensed for CAT Max operation as well. And finally, the subscriber radio. So the portables and mobiles do also need to be licensed to work on a CAT Max Tier 3 trunking solution. Said the CMSS, the centralized system server, it contains the system controller function, so it controls all the calls on the system. controls the radio registration and the authentication within the radios on the network. It's also integrated with a voice and radio command or VRC gateway within the CMSS. If we need more gateways or anything like that, it requires the purchasing of another CMSS. Now, the CMSS can be just set up and set up as just purely a voice VRC gateway if required. And as I mentioned, the system and performance management, which is what we call the system advisor, is built into the CMSS. It supports 100 simultaneous voice talk paths. Now, don't think that that's just only 100 calls on the system. We're talking here about external calls from a third-party application. We can support up to 100 voice talk paths. Simultaneous voice paths coming from, as I said, third-party applications. If we do require more, again, we can order more voice talk paths with licenses and more VRC gateways, so they are definitely supported. It is a high availability platform, redundant servers, operational RAID architecture within that. You can see it is a HP server device, and it's also supported embedded application. So when we're doing the system update within this, we run these system update applications to run our network. Okay, guys, I know I've gone a little bit over. Probably part of that was with the problems with the audio. That's the finish of our session today. So as you can see, in recap, we've pretty much covered the radios. The Moto Turbo radios are operational in conventional operation, radio to radio or through a repeater. We can also do a wide area conventional system, which is IP Site Connect, via an IP backbone, or using RF linking via Moto Turbo Link configuration. And then we looked at our trunking solutions, which is the CAT Plus single site and CAT Plus multi-site solution, which is able to trunk the radios within the system, bearing in mind that CAT Plus single site multi-site solution are Motorola only functions. It's not the DMR Tier 3 trunking solution. That is what we call the CAT Max. The CAT Max is a Tier 3 trunking solution which supports multi-vendor. It's to the DMR Tier 3 standard, and it's as I mentioned, it's fully controlled, trunked, managed network. Next week we're going to look at. We made a lot of mention about applications, and we're going to look into the integration of our applications into all our systems, whether we're talking about conventional IP Site Connect, CAT Plus, or CAT Max. Okay, Grant, do we get any questions?
We've answered the one as they've popped up. There was one question. It would be great to have a session on Motorola's POC offering. Guys, we have done a presentation on Motorola's Wave offering. There is a link to the webinar for that one, and I will arrange for you guys to get that. It'll also be on the YouTube channel. So if you guys need to look at these offerings again, jump onto the YouTube channel. If they're not there, give me a shout and I'll send you the links that we've got to the webinars themselves. Those are the only questions that we haven't addressed so far, Elder. So if there are any more questions, guys, toss them up. Otherwise, thank you, Elder, for your time. Thank you for finding the time to jump online with us and just to explain this all to us. And guys, really what I'm trying to achieve here is to give you the tools and the knowledge base to be able to go out there to your customers with solutions. So have a look at the problems, have a look at what they're trying to achieve, and let's have a look at the box of tools that we have to see what we require to give them a solution that's first usable, manageable, and affordable. So, you know, we've got all of the solutions. It just depends on budget and depends on requirement. So really, anything that you guys need, anything that's out there that you're scared of, don't be. Talk to us. Get on the phone, have a chat, and let's see what we can help you with. So, Aldo, thank you, sir. There's no more questions. And guys, as we go through, if you do have questions, drop them to me on an email, phone me, and I'll talk you through it all. You know, we can make this webinar available. You guys will get copies of the slides in the webinar, and it'll help you to build your foundations and your own libraries as to what this product can do for you. It's a powerful product.
Okay, thanks, Grant. So as I said, we'll, next week is covering applications. I do apologise with the audio dropouts. I'm not sure what was happening. I would be told my system would drop out the audio, and then I'd have to wait to reconnect. So I do apologise, but as I said, next week we'll cover off the final session, looking at our applications. Thank you all for your
Thank
time.
you very much, sir. Thank you. Have a good week, everybody. Stay safe, and we'll see you next Tuesday, same time, same place. Thanks, Elder.
Okay, then. Bye-bye.